when you put a number, so like say I did like 109 plus 100 equals 219. I mean 119 plus 100.
What does it not have? What does an expression not have?
Expressions do not have equal sign.
Yep, thank you. The expression does not have an equal sign, and we are using only subtraction today.
Oh, buddy.
Only subtraction. That is your only requirement for this. If you're only using subtraction. So I'm going to give you guys about 3 minutes to come up with an expression or two that equals 219 that uses only subtraction.
Everybody should have more than one expression today. You have 3 minutes to come up with these, and it's only subtraction. You should all have more than one today. There's so much going on in his house every day. Earlier, he was reading his brother. He was like, "What you doing right now?" I see several people like they're writing expressions down right now. Hoffman. Hershey's. You should be writing stuff down.
We have about a minute and a half left.
We have a couple people who would like to turn their cameras on if they're able, please.
All right. Alejandro, what was the expression you created? Paging Alejandro. What's the expression you created? Alejandro. There you go. Alejandro. There you go. What?
What is the up and down one?
No, we're not using, no, we're saying what is an expression you created to get to 219? So
We'll call on so you can see an example, okay? Cynthia, what did you see an example, okay?
789 minus 400 minus 70.
Start over. I couldn't, you talked really fast.
789 minus 400 minus 70.
Yep. So you took 789 minus 400, which equals what?
$700. 389.
Yep. 389 minus 70 is what?
700. 700. 300.
So 789 minus 400 is 389 minus 70.
19.
319. So what else do we need to do to get down to 219?
Minus 100.
There you go, minus 100. Awesome job. Way to use some big numbers. Okay, Jay, how about you?
1,000 minus 781. Watch me. What is I watching? One.
How do you know that one works, Jay?
Because I know 300 minus 81 equals 219, so I added 7 more, and then I had to subtract 7 more to get 300, and then minus 81, that equals 219.
So really, 1,000 minus 700 got you to 300, and then you subtracted 81 from 300 to get 219. You guys are just really going for it today. All right, Alejandro, we're gonna come back to you. Wherever you went.
So I subtracted 419
Minus what?
200
Yep, that one works.
and got 219.
And got you 319. Good job, guys. We're gonna end 10-minute math there today, and Mr. Hoffman's gonna talk to you about our goal.
Ania, can you read our goal for us since I just saw your hand up? Please and thank you.
Modeling and solving word problems that involve multiplication, comparison.
That's a tough word. You're close. Multiplicative comparison, right? So yesterday we worked on multiplicative comparison problems, right? Where it said one thing was like 8 times larger than the other. Or someone drove 6 miles, someone drove 8 times further. How far do they drive? We're going to work more on those today. Excuse me. But we're going to kind of go more in depth at looking at some more challenging versions of those problems and kind of how that might go. So I want to take a quick look at number 5. This was one of the options you could do yesterday, and it's kind of a pretty challenging one. Eric, that girl's name is Amelia. Can you read the problem about Amelia? Please and thank you, Eric.
Amelia has 24 marbles. She has 6 times as many marbles as Steve. How many marbles does Steve have?
Thank you, sir. So this is where it becomes really important to understand how to make our models and our drawings to help us really understand how to find answers. All right. Let's see. CJ, what is one thing in this number that we should probably circle that is important for us to understand? CJ in here?
24.
Right. Yeah. So Amelia has 24 marbles, right? So I'm going to circle 24 marbles, and those belong to Amelia, right? Then what is something else that's important for us to notice in the problem, Clay?
She had 6 times.
Yeah, she has 6 times as many as Steve. Very good. And then what is the last thing it is asking us that we should Henry, what's it asking us to figure out?
They're asking us to figure out how many does Steve have.
Right. How many marbles does Steve have? So in this problem, who do we know how many marbles they have already? And anybody can unmute. Who do we know how many marbles they have already?
Amelia.
Yeah, we know Amelia has 24 marbles, right? So I'm going to just write Amelia. Sorry, the dark blue is hard to see. We're just going to write Amelia equals 24 marbles. Okay. So what this is asking us is tricky, right? We have to really pay close attention because it says she has 6 times as many as Steve does. So who has more marbles? Give me a thumbs up if you think Amelia has more marbles. Right. I need to see everybody's thumbs up at one of these two. If you think Amelia has more marbles, give me a thumbs up. Thank you. Thumbs down. If you think Steve has more marbles, give me thumbs up. So we're kind of split between the two. All right, so this is where I want to review the language. Go ahead and put your hands down. If it says she has 6 times as many, that means Amelia has more, right? It doesn't say Steve has 6 times as many as Amelia. So what we might want to think about this problem is our initial instinct might to say we have 24 and it says 6 times as many. We're going to do 24 times 6. But that's what's tricky, right? Because this is saying we have 24 and Amelia is the one who has 6 times as many. So instead of, if we go back to making that chart, right? We know that Amelia has 24 total marbles. And we know that she has 6 times as many. So she has 6 groups compared to Steve. So we're trying to figure out the objects per group. I like OBP, objects per group, right? So we know that she has 6 times as many. So if I want to do this, if there's a question mark in the middle, my equation would look like what? What's an equation I could write, even if I have a blank in it, to solve this problem? What's an equation that I could write down? Blank times blank equals something, or something divided by something equals something. Somebody be a risk taker here and share with us. What do you think? Jay, what do you think we could write down?
24 divided by 6.
Yep. We're doing 24 divided by 6 on this one. Or another way to think about it is 6 times a number that we don't know yet equals 24. So some of you guys might already know that, but let's make a model to show how many more Amelia has compared to Steve. So if we think about it this way, sorry, I'm going to minimize this for a second. If we think about it, we're going to say, here is Steve's group of marbles. We don't know how many are in there yet. This is Steve's, right? And we're going to put a question mark. And then Amelia has 6 times as many. So we're going to go 1, there's how many Steve has, but we have to do it 6 times. 2, 3, 4, 5, 6, right? That's Amelia's. And now we have 24 marbles that we need to split up evenly in those groups to understand how many more she has than Nick, or Steve, sorry, how many Steve has. I have no idea where I got the name Nick from. So we're going to go 1, 2, 3, 4, 5, 6. What number am I going to stop at? You can just unmute yourself and tell me.
24.
Thank you. She has 24 total. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So now our groups are even. If we draw a line straight down from Steve to Amelia, we can see how many marbles are in that one group. Everybody, hold up on your fingers. How many marbles were in that one group? Very good. I'm seeing a lot of 4s. So we know that Steve has 4 marbles. So our answer is going to be 4 marbles, right? Or we could say 24 times, or 6 times 4 equals 24. So those are tricky. So sometimes when we already know, you have to pay really close attention to the wording. Because if the person who has more has 6 times more than somebody else, and we already know their total, we're going to have to divide. You aren't going to see those very often, but every once in a while, problems like that one are going to come up, all right? I'm going to hand things over to Ms. Weibel, and she's going to talk you through another situation in these comparison problems that can be kind of tricky.
Okay, so here we have 2 problems, and we're going to look at the similarities and the differences within these problems. Denise, can you read number 1, please?
In a zoo,
You froze for a minute. Can you start over? We're gonna still be playing.
Eastern Diamondback rattlesnake that is 6 feet long and a reptile
Reticulated, that's a hard word. Reticulated.
particularly
Python.
python that is 4 times as long as a rattlesnake. How many feet long is a python?
Thank you. And then Alex J, can you read number 2?
What was the question?
Can you read number 2?
In the zoo, there is an eastern diamondback rattlesnake that is 6 feet long and a
Reticulated.
reticulated python that is 4 feet longer than the rattlesnake. How many feet long is the python?
Thank you. So first, let's look at the numbers that are in these 2 problems. In the first problem, we have the diamondback rattlesnake is 6 feet long. And Jay, how long is the python? What does it say about him or her?
That it's 4 times as long as a rattlesnake.
Yep, so the python is 4 times as long as the rattlesnake. And then Alejandro, what question is it asking me?
How many feet long is the python?
Yep, how many feet long is the python? And in my second problem, looking at number 2 now, it says, in a zoo, there's an eastern diamondback rattlesnake that is 6 feet long. So the diamondback rattlesnake is still 6 feet long. But what does it say about the reticulated python? Clay. Not paying attention.
Clay, you got called on. What does it say about the reticulated python in number 2?
I'm sorry, I couldn't hear you.
What is it? Number 2, what does it say about the reticulated python? I already underlined it. In the first one, it says it's 4 times as long. And in the second one, it says it is okay, it says it's 4 feet longer. And then
I forgot to turn my mic on again.
it's okay. It's all right. CJ, what is it asking me in number 2?
It's asking you how many feet long is the python?
Yep. So both questions are asking me how many feet long is the python. And in both questions, the rattlesnake is 6 feet long. However, in the first one, it says that the python is 4 times as long as the rattlesnake, right here. And in the second one, it says that the python is 4 feet longer. Okay, so I am going to give you guys a couple of minutes, and I just want you to do your best and solve both of these problems. All right, you're going to solve number 1 and number 2. And we're going to talk about what's
Pay close attention to that difference in language that Ms. Weibel talked about on number 1 and 2. That's why we left up the ones that are underlined. Pay close attention to the difference in language on the 2.
Please keep your videos on, boys and girls.
We're going to give you guys about 1 more minute. All right, we're going to come back together. And I'm going to let Ms. Weibel have somebody talk her through what you did to solve number 1. So if you'd like to share how you solved number 1, or like what you drew to help you solve number 1, talk us through that. Is there anybody who would like to share what you did to solve number 1?
Not the answer, how you got it.
Michael, go ahead. I saw your hand go up.
I did 6 times 4 first.
Okay, and how did you know to do 6 times 4?
Because it said that it's because I see the 4 and the 6 and it says times is long, so times means it's up some more, so I'm guessing that it's gonna be multiplication.
And you just know the math fact 6 times 4? Did you do a drawing or anything like that to help you?
Kinda, but
Okay.
I don't know.
We'll let you think on that more. I think you're on the right track. Is there anybody who did a drawing or made a model to help them solve it for 6 times 4? Ania, how did you do it?
I did, so I did 4 circles and I put 6 dots in each circle. And then I counted it.
All right, and what did you get for your answer?
24 feet long.
Okay, thank you. And on your drawing, Ania, what do the 6 dots in one circle represent?
The 6 represents for the eastern diamondback rattlesnake.
Very good. So the 6 dots in one group show how it's 1 foot, right, for the diamondback rattlesnake. What do all 24 represent? The 24 feet of what?
Of the python.
Very good. So I'm going to that's excellent. I'm glad you did it that way. I'm going to kind of do a drawing as an example of what some of us have to maybe help some of us how we might think of this too. really quickly. So if you guys make sure you're paying attention to the screen. So it would be like saying, if this is our diamondback rattlesnake, right? I'm drawing right here. So there's our diamondback rattlesnake, feet long, right? So if we're saying that python is 4 times as long, diamondback rattlesnake, we would have one of the pythons, right? So we could kind of imagine like 1, 2, 3, 4 of the diamondback rattlesnake, right? And this is like, it kind of looked like worms, but that's okay. So there's our rattlesnakes laid out side by side, and there's 4 of them, and each of them is 6 feet long, right? And then underneath them, we have this one big python, right? And he is the same length as 4 of those rattlesnakes next to each other because he's 4 times as long. So then that whole thing down here would be 24 feet. So it's fine if you like to draw the circles and use that to represent your group. That is totally fine. But it's just we have to make sure we understand what those circles mean. Ania could tell us exactly what the circles meant, and instead of just saying 6 times 4. But another way to think about it is if we drew out those snakes next to each other, that python is the same length of 4 of those rattlesnakes because he's 4 times as long. All right. How about number 2? Anybody want to talk with Miss Weibel about how you did number 2? So nobody. So that means I get to pick. Henry, how did you solve number 2?
I solved number 2 by just using the circles.
Okay, so what did you do for number 2 then?
So I drew 6 circles, and then put each 4 dots in each circle.
Okay, so here's where we're gonna freeze. Okay, because this is why I think drawing the snakes is the helpful thing to do on this one, right? Because Henry, how long does it say our rattlesnake is in number 2?
A rattlesnake is 4 feet long.
Oh, look at it says an Eastern diamondback rattlesnake is 6 feet long, just like number 1, right? So there's our rattlesnake. He's 6 feet long. Somebody besides Henry, help us out. What does it say about the python on this one? What does it say? Corbin, what's it say about the python in number 2? The python is what?
The python is 4 feet longer than
Thank you. So it's 4 feet.
diamondback rattlesnake.
It's 4 feet longer. So on this one, are we multiplying 4 rattlesnakes together to get the length of the python?
Yes.
We are. Does it say 4 times as long? What does it say? 4 feet longer. So I want you to freeze for a second, y'all. And I need to make sure I got people's eyes closed. I got people looking off in the distance. If none of us are able to share what we should be doing on the drawing, then we should be looking at the screen, being ready to listen to the problem. All right? So if it says it's 4 feet longer, if I do it 4 times, let's look at how much longer that would be. That's what we did up at the top, right? So 4 times as long as 6 feet, if I circle it, it's 6 more feet and 6 more feet and 6 more feet. So that would be 18 feet longer if I'm 4 times. So I'm not multiplying this one times 4, because if I was, that's going to be 18 feet longer. All it's telling us is that this python is 4 feet longer. All right, so we are just adding 4 more feet to the end of our rattlesnake, right? That's that 4 feet longer that the python is. So when I draw out that python, what am I going to do to find the total length of that python? This one's a little tricky. What do I have to do to find the total length of that python if it's the rattlesnake's 6 feet long and the python's 4 feet longer? You got your drawing right there. What do I need to do with those 2 numbers? Am I multiplying them? Y'all got to give us something. I have a bunch of people just staring blankly at me. Clay, what am I going to do?
You're going to multiply 4. You're going to multiply 4 6 times.
Why would I multiply 4 6 times?
Because there is because 1 snake equals 6 feet.
Yep.
And then since there's sorry, I'm taking some time.
Okay, what's it say about that python? It says it's 4 feet longer. This is what happens. We have been doing multiplication so much lately that we get stuck in this world of multiplication. And we think, I see that number 6 and I see that number 4 and I have to multiply. But if it's 4 feet longer, we have that. Look at our first drawing. The first drawing shows us a python that is 4 times longer. There's 4 of the rattlesnake. We did a drawing where we showed we had a rattlesnake that was 6 feet and we added 4 feet to it. So we're not multiplying for that rattlesnake. What are we doing, y'all?
Adding.
We're adding 4 feet, right? We're saying this one's 6 feet. We're adding 4 more feet onto it to get our total of how many feet, Jay?
10 feet.
10 feet. So in that second one, that python is 10 feet long. That's where we get that we have to pay attention to what the problem tells us, because we get caught in, I've been doing multiplication, I have to multiply, right? Whereas if I had showed you that second problem, this is what's funny, right? If I had showed you that second problem by itself and we had not been doing multiplication and you hadn't seen the one on top of it, I bet almost everyone in here would have done 6 plus 4 equals 10. Because I've seen you solve problems like that already. But because we've been doing multiplication, you all thought we had to multiply, right? So you have to pay close attention to what that problem is truly asking you to solve. It gets tricky, all right? That's it for our lesson today. So your job moving forward is we have a comparison problem quiz on Canvas, and then you're going to go get it done, all right? There are specific directions that we need to follow on this quiz on Friday under math. Comparison problem quiz. It says solve each problem. The following question will ask you to explain how you got your answer for the previous question. You will receive points for explaining your answers. So when you look at the quiz, sorry, excuse me. The first one says, over the summer, Naomi read 9 books. Say read 4 times as many books. How many books did Say read? You're going to find your answer. And the next one says, how did you get your answer for number 1? Explain your solution. And you have to type in your answer. So you're getting 1 point for number 1 and 1 point for saying how you got it. They're all like this. Question 3 is Benson's tomato plant is 3 feet tall. His corn plant is twice as tall. How tall is his corn plant? How did you find your answer? Okay, that's your job today. It's 3 problems and 3 explanations. All right, I'm going to stop my share. I'm going to stop my recording.